Alright, so that was 14, I think it was. 14. 1.1, number 14.
No, I was talking about 23. Sorry.
23. That wasn't even part of your assignment.
Yesterday.
23. 3 halves
23.
equals 9/10 times k.
Yeah, that one. Thank you. Sorry.
You. So again, just in the future, have that ready. You
Okay.
can just say 23. So what we want to know is, what is k worth, right? Well, right now we know what 9/10 times k, or 9/10 of k is. We don't know what 9/10 of k is. We want to know how much of k. Like, what number would we like to have here multiplied by k? 1. What's 1 times k?
Okay.
K. Just like 1 times anything is the anything that you just multiplied by 1. Is there a way to, like, can I do some kind of a operation with some number that would result in a 1 times k instead of a 9/10 times k? Yes?
You switch the 10 to the top. Is that what you're talking about?
Switch it to the top.
Like reciprocal.
What about the reciprocal?
Just switch it.
Or just k over 1.
Okay, so we take the reciprocal of 9/10 and multiply by it. Right? We gotta do something with it. Why? What happens when we multiply 9/10 by 10/9? What do we get?
91.
90 over 90 is 1. Great, that's 1k, right?
Yeah.
We just need to make sure we do the same thing to both sides. We get 30 over 18. We can simplify this fraction, Colby.
What do you do? Mixed fractions would be 1.
Well, let's first simplify, because these have a common factor, right?
So divide by 2 and then
Divide by 2 both?
yeah, and that's 15 over 9.
Uh-huh.
And divide by 3.
Divide by 3 as well.
And then you get 5.
5 over 3.
Or yeah.
Or
1.
1 and 2/3.
Oh, I get this now.
1 times k. We want k plus 0. We want k divided by 1. Why are all these things what we want? Why would I want a k times 1? Jasper?
Because k times 1 is just k.
Right. What about k plus 0? What's that? K. And what about k divided by 1?
K.
K. And what about squares and square roots?
No, no, it's not.
Okay. Well, for now, that's everything we know. We want to get k plus 0, 1 times k, k divided by 1, because all of these things are just the same as k. In this example, we wound up getting 1 times k. We didn't have to worry about plus 0, because there was nothing added or subtracted, so we didn't have to mess around with that. Colby?
Can we do number 42?
I'll look up 42, and then I will continue.
Why do you, shh. Oh, that's a question.
Why did we what?
Divided by 2. 30 over 18.
Just simplifying this fraction, they're both divisible by 2. Divide this by 2, we get 30. Divide this by 2, we get 9. No. They're equivalent to each other. I take 30 divided by 18, I got 1.66. 15 divided by 9 is 1.66. 5 divided by 3 is 1.66. Repeating forever.
Okay. And then how can you get 1, 2, 3? Is it 5 and 3?
5/3 is 1 and 2/3. Just writing it as a mixed number. 42 is one about pictures. Okay, so 1/4 of girls and 1/8 of boys in a class retake their school pictures. Okay, so they have a picture they don't like so much, or maybe they missed that day. So they come in and they retake their pictures. So 1/4 of the girls and 1/8 of the boys do that. The photographer retakes pictures for 16 girls and 17 boys. How many students are in the class? So we're gonna write an equation.
There's 7 boys, not 17.
What's that?
There's 7 boys, not 17. He has the book. It was 7. The book says
It is 7 boys.
7. Totally knew
Did
that.
I say 17?
Yeah.
Okay, so I misspoke. Okay. We're gonna write an equation. Yes? Okay.
How many girls did you say?
You said
Oh.
16 girls and 7 boys.
So like 1/4.
That's what I did. I wrote a fraction and I converted those two into a fraction of the class and then I added like,
1/4
I did 1/4 equals 16 over x.
equals 16 over
And then I
x.
multiplied 4 by 16.
We set up a little proportion here, okay?
And then I got 64 and I did the same thing with 7. With
So
7.
4 times 16 equals x. 48? No, 64, not 64.
And then I did the same thing with the boys, so I did 1 over.
We said 1/8
Yeah,
equals
equals 7 over x.
7 over, we call b the boy.
Stop. And then with that I got, huh?
I don't care what you're talking about. You're distracting people.
And then I did 8 times 8 equals b, which was 56.
56.
And then I added the two, those two. I
Add
added
2, you get 120.
Yeah.
Yeah.
Move right here, please, Hunter. So we add the 56 boys to the 64 girls, we get 120 students. Hunter?
Okay, so when you have a math problem and entering like an progression gets turned into these number? So if it was just, what, that last one we just did, if it was just like k equals 5/3, that would be okay, so.
5/3, yeah, 5/3 would be fine. Okay, it's 42. We ready to go to 1.2 now?
Sure.
1.2, okay.
That was very sarcastic.
Did sound sarcastic, Sid.
Alright,
That's what sarcasm is.
sure,
It's
why
like-
not?
Sure, why not?
I got 7. Go away.
Is that
I can't even go that high.
7 what?
Number 7.
You have a question about 7?
Yes.
Okay. That nice cave down there. Okay. 19 minus 4c equals 17. And, you know, if this was x plus 19 equals 17, I think we would have no problem there. If this was negative 4x equals 17, I think we'd know what to do then. Right? If we had x plus 19 equals 17, how would we solve that equation? Ready?
Minus 19 on both sides.
And x is negative 2, right? And how would we solve this equation?
Negative 4. Or divide by 4 on each side.
By
Negative.
negative 4, and x is negative 17 over 4. Okay? But here we have both of those things. But you can see that since there's a plus 19 and a negative 4 times c, the subtracting 19, the dividing by negative 4, it's going to come about somewhere in this problem. So what would you suggest we do first?
Plus 19.
Plus 19?
Oh, like,
Minus 19.
Minus 19 instead? What's 19 minus 19?
0.
Is that good for us?
Yeah.
Because we get 0 minus 4c. What's 0 minus 4c?
4c.
Almost.
Negative
Negative 4c. Subtract 19, so we get
Negative.
negative 2.
And then divide
divide by -4. What's -2 divided by -4?
0.5.
1/2. Yes.
I was 0.5.
Is 1/2 the same as 0.5?
Yes.
1/2 and 0.5, they're the same. Yes.
And then can you make 33 on 1
Wow.
Very well.
Oh, that would be.
Right. Instead of trying to like do things on both sides right now, could we simplify the way it looks before we even get started on that?
Yeah.
How so?
8
Sid?
divided.
You divide by 2.
8 divided by 2. Okay? It's just an order of operations thing. You look at this 8, right? Would we add it to h if we knew what h was?
Yeah.
No.
No.
we divide by
Because
10.
Order operation.
order of operations that we agree to use, we divide first, right? So this is kind of its own little chunk. 8 divided by 2 is 4. H plus 4. 3. That's easier to look at. About -4 on both sides. H equals -7. Done. We are finished.
Amazing.
I have to take that right tomorrow. The only reason I got it wrong is I did times 2, then I did the opposite of them.
Uh-huh. Yeah, so the thing about that is when you multiply by 2, you have to multiply, when we're working this with these equations, we always make sure that what we do to one side, we do to the other side, right? The key word there is kind of side. I do it to one side, I do it to the other side, not to just parts of it, but all of it, alright? So, if I were to multiply this by 2, it means I would multiply all of this by 2. Okay? Which means that I'd have to do what with this 2 to multiply by this? Parentheses here? Have to
No, you're carrying.
distribute.
Distribute, yeah.
Distribute the 2. Distribute the 2 to the h and to the 8 divided by 2. And we'd have to multiply by 2 over here. That would look like -6 on this side, on the left side, equals 2h, 2 times h, plus 8, because that part of the plan worked, right? It undid that dividing by 2. But now we have this equation to solve, which is fine. It will also give us -7. But we just, it's going to take a little bit more time, right? We would subtract 8 now and get -14 equals 2h. I'm just going to let this run for a while because I hear this constant chatter that just never ceases. Okay. -14 equals 2h, and we do what to solve for h?
So you divide by 2 and you
Divide by 2, divide by 2,
And you
h
get
equals
-7.
-7.
So you still can get this answer.
Yeah, you're gonna get the same answer as long as you do everything correctly. You just multiply by 2 and then say, oh, that cancels the 2, but you just have h and not 2h, then it's not gonna give you the right answer. Hunter?
20?
20.
6 equals -w or h.
This is the last one that I'm gonna do from 1.1. That's number 8. You might think, well, I'm just me talking. So it doesn't cause any problems. But you're like rocks in the middle of a river, stopping the river from flowing smoothly. Okay? It slows us down ever so little. You lose time, and it's a waste of the time that you're here. You're here to do what?
Learn.
Learn math.
So let's stop trying to take every moment that my back is turned to talk about whatever. Let's act like we're here to learn math. I'm here to teach it to you, act like you're here to learn it. Okay, so on this one side we have negative w over 8, on the other side we have 6. We don't have anything added or subtracted, right? So we're not going to try and get 0 here. What we want is w times 1 or w divided by 1, because either one of those is equal to what?
One.
Is equal to
Well,
One
w is equal to w. 1w is a w. That's what we want to know. We want to know what w is worth. So I think some people will think of it this way, some people will think of it this way. Either way, if we can get either one of these, we'll be in good shape. Right now what we have is a negative w divided by 8. We want a positive 1 times w, or a w divided by a positive 1, or a positive w divided by 1, however you want to think about all that. So let's just tackle each problem individually, like the negative. How do I get a negative to be a positive? Times it by a negative. Negative times negative is positive. Okay?
Times it by the reciprocal.
The reciprocal of what?
The negative.
There's no,
I mean, like,
there's no
never
number
mind.
there yet.
Like the reciprocal, we've seen reciprocal before, right? We get a 1 times the variable.
1 over, 8 over 1.
8 over 1? That might work. Okay. So far, we're just messing around with the right side to see if we can get a w times 1 or a w divided by 1. Okay? Let's see what happens. Let's just see what happens on the right side, and if it works out, we'll just do the same thing to the left side. Okay? Let's see. We got a negative here times a negative. What's a negative times a negative? A positive. That's good. Right? Positive. So we'll just say it's going to be a positive. So we got 2 fractions here. How do we multiply fractions? Straight across. What's w times 8? 8w. What's 8 times 1?
8.
We got an 8 down here.
8w over 8.
Is this good?
Yeah.
Yeah.
Why? What is 8w over 8?
1, 8.
1.
1 w.
8.
W. What's 8 divided by 8?
1.
1. We got 1w. That worked out.
And then you do that.
So we'll just do the same thing the other side. I'll just multiply by negative 8 instead of negative 8 over 1. It's not a fraction over there, so we'll just do it an easy way. So negative 48 is w. You could do it piece by piece by piece if you want. Like, well, to start with, I know I don't want a negative, so we can multiply this by a negative 1, right? Negative times negative 1 is positive. So I might as well just do that. Right? Negative 6 equals, you know, that feels a little better. At least it's positive. And then we have this 8 in the denominator. And maybe we get the idea to multiply by the reciprocal, right? Which is 8 over w. But then the w and the 8 get canceled out. Okay? Olivia, phone jail. So the w and the 8 both get canceled out. That's not what we want. We want the w to stay, don't we?
Yeah.
So how about if we just make this a 1 instead? Right? W stays, 8 divides 8, and we'll multiply this by 8. Negative 48 again. W. Just want you to think about how to get just a w. 1w, w plus 0, whatever you need to get so the w is by itself. Like I said, that was the last one from 1.1 that I'm going to do. No. Anything? Well, we did. There's only 2 questions from.
Yeah. Yeah.
Should we do 6?
Sure. No.
No?
Yeah.
No,
Yeah.
I hear some yeahs, so let's
I
go ahead and
did
do it. 6. I hear it starting to get loud for no reason. It's not helping anybody. the record, I don't mind people talking. It's just that you don't know how to choose your moments, period 5, 8th grade math. You don't know how to choose your moments. Your moment, any moment of silence. You're choosing your moments wrong, okay? A little bit of talking as we hand in our homework, great. Talking all the time while I'm turned around, not working. All right, so we have 10x plus 2 equals 32. Ideas for what we can start with, Marcus.
So divide, or you can subtract. I divided.
I'm going to subtract, and I'll
Okay.
show you why. Minus 2 minus 2, 10x equals
30.
30. Anybody disagree with that?
No.
10x equals 30? Okay, Mac?
No, I don't disagree.
I mean, you had your hand raised, so
Oh.
what do you have to say?
Oh, well, cause you divide 10,
Right now?
yeah.
Divide by 10 on both sides,
And then you
and x equals 3. Okay, now, we can do anything we want, really, to both sides. There's a lot of things that would be really weird and not helpful to do, right? Like 10x plus 2 equals 32. I could add 7 to both sides. That doesn't really seem to help. I could divide by 12, but that really doesn't seem like the right idea. I could multiply by 17, but that doesn't seem like it would have any effect that was good. Okay? If I choose to divide by 10 right now, can you divide by 10?
yeah.
The answer is always yes, you can, as long as you do what?
Both.
Both sides, okay? Anything can be done. Anything. Not everything is a good idea, but everything could be done. Now, let me show you what it looks like to divide by 10. Let me show you what this equation looks like as a scale. So on this side we have 10x. Let me show you what 10x looks like. Okay, work with me, pen. And I'll just make this fast. Okay, do you see what I'm saying there?
Yeah.
10 of those little containers that we talked about on the scale over here. 10 of these x's, so we don't know what's in there. Plus 2. There's also 2 of those white little coins, right? And on this side, 32. I'm going to be here a while, right? So 32 of those tokens.
Curly cues.
Can we all imagine that there's 32 there? I don't want to
Yeah.
take your time up and draw them. Okay. So the idea is, let's divide by 10. Let's look at what it looks like to divide by 10. You want to take 1/10 of this side. How do I look at 1/10 of this side? Divide this side by 10. Cut it down and have only 1/10 of it left.
So you take 10 from each side.
Well, it's not subtraction. I'm not taking 10 away, right? I'm dividing by 10. Can you divide this part by 10?
Yeah.
Yeah. What would this be divided by 10?
1.
Yeah, we would just, when you divide by 10, you just have one of those. But the thing I'm trying to get you to see is we'd also have to take 1/10 of this. Otherwise, we haven't taken the whole side and divided by 10. So we have to divide these two things into 10, which, how does that sound? Kind of like not that easy to do, right? I'd have to take these two and divide them into 10 pieces each somehow. Okay, and I'd have 1/10 of that would be 2/10. So if I divide by 2, I have to divide, if I divide by 10, I have to divide everything by 10 on this side, so I get x plus 2/10 equals 32/10. See what I'm saying?
Yeah.
I'm going to divide by 10, I have to divide everything by 10. So you may think, well, I'll divide by 10 and I'll get x plus 2. But that's not the case, because we would have to cut this whole side down by 10. We have to look at 1/10 of this entire side, which if we only look at 1/10 of this, we're not taking 1/10 of everything on the left side. If we continue now, now that we have divided by 10 correctly, we'll still get the right answer. What would you do to solve this equation?
Times 2/10.
No, you divide and then you get 1/5.
You got
Oh, it's plus, minus.
x plus 2/10, so minus 2/10. What's 2/10 minus 2/10? 0. 2/10 minus 2/10 is nothing, it's 0. Minus 2/10. Can I subtract 2/10 from 32/10?
Yeah,
Why am I allowed to do that?
because they're common.
Common denominator of the same size, right?
30.
32/10 minus 2/10 is 30/10, which is 3. Now we only got the right answer because when we chose to divide by 10 on both sides, we did it correctly. We divided by 10 on both sides. So my suggestion to make these two-step equations as easy as possible would be to subtract or add, depending on what sign this is. Yeah. Right? Get 0 first, and then divide. So add or subtract to get 0, and then divide. Okay? Does that make sense? Let's look at one more, just a made-up practice one. 5x plus 9 equals, if you were to follow my suggestion, what would you do first? Yep. Subtract 9 first. 50, and then divide by 5. Get x equals 10.
You do 15 over 8 times 8 over 15.
Perfect. We get
Which is 1.
it's 1. It doesn't really matter what it is over what. It's 1.
And then you do that to
The other side over 1. So we get x equals, well, let's see, 8 and 12 have a common factor of 4. 2, 3,
So
15, so 45 over 2.
this is about 20.
Yeah,
I've got
180.
22 and a half.
Yeah,
X over 9 equals 5.
same thing.
What's that?
Okay, so then if you times 9 over x and then you times 5 by 9, which is 45.
Wait. If I multiply this side by 9 over x, I have to multiply this side by 9 over x.
But you
9 over,
X.
okay, over x. Well, 9x over 9x. What's 9x over 9x?
1x.
That should be 1. Equals 45 over x.
Oh, you're supposed to.
What do you put this like x equals 45? Is that wrong?
Well, it would not, I mean, I guess you can see that 45 divided by x is 1, so x would have to be 45. But we can fix this just by,
Crossing out here.
instead of x, make that a what?
1.
Let's do a 1. So now the x stays, the 9 cancels the 9, and we get x equals 45 with no extra steps.
Right or wrong?
No,
It's
x
still
is
right, it's still
45.
right.
We are going to finish this one, so the less you fidget and zip and turn, the faster it goes. First thing we would do here, Marcus,
Plus 3 on each side.
plus 3,
And then
5x
5x
equals
12
12
divided
divided by 5.
by 5. And then it's 2.4.
12 is something.
It's 2.4.
Have a good day.